Differences between VAR, VECM, and ARDL. VAR versus VECM versus ARDL. VAR or vector autoregressive models are used to model the dynamic interrelationships among multiple time series variables. Here, each variable is regressed on its own lagged values as well as lagged values of other variables in the system. VAR models do not consider long-term equilibrium relationships among variables, whereas VECM or vector error correction model estimation requires the determination of lag length, trend specification, and the number of co-integrating relationships using Johansson's test. Whereas ARDL or autoregressive distributed lag co-integration technique is used in determining the long-run relationship between series with different order of integration. The reparameterized result gives the short-run dynamics and long-run relationship of the considered variables. The purpose of VAR model is to capture the relationship between multiple quantities as they change over time. Whereas, the purpose of VECM model is establishes a short-term relationship between the stock prices, while correcting with the deviation from the long-term co-movement of prices. Whereas, the purpose ARDL techniques is to analyze the relationship between two or more variables and handle both stationary and non-stationary data by incorporating lagged values of variables as well as their differences to capture short and long-term dynamics. VAR models are widely used in time series research to examine the dynamic relationships that exist between variables that interact with one another. Whereas VECM model is used to analyze co-integrated variables or co-integrating relationships. Whereas ARDL co-integration technique is used to examine both long and short-run relationships between variables. Further, ARDL model are useful when the variables are integrated of different orders. VAR model helps in time series research by allowing one to inspect the dynamic relationships between the variable interacting with each other. This model is of three types: structural, recursive, and reduced form. Whereas VECM models can help us to better understand the nature of any non-stationarity among the different component series and can also improve longer-term forecasting compared to an unconstrained model. Whereas ARDL models helps in analyzing the relationship between two or more variables in a single equation framework and can handle both stationary and non-stationarity time series variables. VAR models are important because it's widely used in time series research to examine the dynamic relationships that exist between variables that interact with one another. In addition, they are also important forecasting tools that are used by most macroeconomic or policy-making institutions. Whereas VECM model are important because it widely used because it allows us to estimate short-run as well as long-run coefficients. Using VECM estimation, we can analyze long-run equilibrium relationships among variables and short-run deviations from that equilibrium. Moreover, the adjustment coefficients show us how the short-run deviations or disequilibrium are corrected. Whereas ARDL models are important because it can capture both short and long-term dynamics. VAR models are suitable for short-term dynamics, whereas VECM models are suitable for long-term equilibrium relationships. Whereas ARDL are suitable for incorporating lagged values of the variables as well as their differences to capture short and long-term dynamics. The general equations of VAR model, VECM, and ARDL are given for comparison to get idea how both method can work from scratch. The results of VAR, model, VECM, and ARDL, when entered data from MS, Excel to eViews or Stata software, by giving proper steps or commands by getting above results. This example of VAR, model, VECM, and ARDL are given for idea for beginners. There are three assumptions of VAR. Models such as the error term's conditional mean is 0. The possibility of large outliers is low and variables within such a model are stationary. Whereas, select VAR when dealing with stationary variables and short-term dynamic relationships. Select VECM when dealing with non-stationary variables and the presence of co-integration relationships. Selecting between VAR and VECM hinges on data stationarity and co-integration. Whereas, there are certain assumptions for ARDL, model to be used such as the variables x and y are stationary. The expected mean value of the error term UT is 0. The error term is serially uncorrelated and the x variables are exogenous, at least weakly so, uncorrelated with the error term. In short, VAR or vector autoregressive model refers to a type of stochastic model that relates a variable's current observations with the past observations of itself and other variables within the system. It captures the interdependencies and evolution between different time series. Model is used in econometric and finance as it offers a framework for fulfilling crucial modeling objectives, including forecasting, structural inference, policy analysis, and data description. Whereas, VECM are econometric models used in time series analysis and its estimation requires the determination of lag length, trend specification and the number of co-integrating relationships using Johansson's test. VECM models to account for long-term equilibrium relationships among variables. It is suitable when variables in system are co-integrated, meaning they share a long-term relationship despite short-term fluctuations. VECM includes an error correction term that captures the adjustment process of the variables back to their long-run equilibrium after a shock or deviation. Whereas, ARDL model is considered as the best econometric method compared to others in a case when the variables are stationary at lag 0 or integrated of order lag 1. ARDL is a better model than others to catch the short-run and long-run impact of independent variables on dependent variable in time series data. The ARDL approach is suitable for generating short-run and long-run elasticities for a small sample size at the same time and follow the ordinary least square (OLS) approach for co-integration between variables. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.